So here's where we left yesterday. We have a particle traveling on the x-axis with this position function. We want to know when the particle is furthest to the left and furthest to the right. Two things that I said during particle motions, the lecture for particle motion, that are really important. There's a couple that aren't, but almost every question in particle motion is a question from somewhere else, just with different vocab around it. So here's a good example of that. When I ask when is the particle furthest to the left, furthest to the right, those are absolute min and absolute max questions on the position function. The largest value you can get out of xp or x of t, I crossed that p off yesterday because it's just not that type of question. The largest value that you can get out of x of t represents the position where that particle is furthest to the right, and the smallest value represents the position where that particle is furthest to the left. So this is the same question as what is the absolute min and what is the absolute max of x of t. The one extra thing that you always have to do in a particle motion question is write down the connection explicitly for them. To figure out when the particle is furthest to the left and furthest to the right, we need the critical values. But in the world of particle motion, those critical values are when the velocity is zero. Because if the particle is going to reach its furthest place to the, I guess you're looking at me and I'm going left, then it has to stop and start going in the other direction, right? Like otherwise if it keeps going in that direction, it hasn't gone the furthest to the left. So it has to stop and come back and go the other direction. So that's the key. We want to, because we're doing particle motion, we want to know when the velocity is zero, but that's the same thing as finding a critical value, specifically when the velocity is zero. And it also could happen when it's undefined, but usually when you have an equation like this, we're looking for when it turns to zero. Okay, so that being said, let's find x prime. This one threw a couple people. I think this is a good, because it threw a couple people, this is a good time to talk about it. The must know for ln is 1 over x, right? That 1 over x is 1 over the argument of the ln function. And I saw a lot of people actually just put 1 over x in their derivatives, which was super weird because the function was in terms of t. But that 1 over x, and I think it's just different with ln because usually the argument stays in parentheses. But in this case, the argument is just kind of coming out of those parentheses in the way that the thing works. So we've got to do the chain rule, and here's what we end up with. Our argument is t squared minus 2t plus 5. Baked in there is that thing can never be negative. Otherwise, the particle could not be traveling on the x-axis with this function because the function would be undefined. And we end up with the chain rule part, which is 2t minus 2, over the ln part, which is 1 over the argument, t squared minus 2t plus 5. And the whole function was negative, so that means that the whole derivative needs a negative. Yeah. So keep in mind that ln derivative, 1 over x, represents 1 over whatever the argument of ln is. So if you have a chain rule problem, that argument goes in the denominator. Okay, so that denominator will never be 0, so we'll never get a critical value where v of t is undefined. But we will get a 0 in our numerator, and that should be kind of almost by inspection what t value gives you 0. 1, yep. So setting that equal to 0 tells us that t equals 1 is when our particle changes direction. I think yesterday I said too that we needed to have a domain restriction here because otherwise this thing goes off to infinity. So let's pretend the problem said t is less than or equal to 0 is less than or equal to 4. Just a number I made up, but that's what the problem said. So we will make a table of t values and what values? Oh, sorry, no. Yeah, I get what you're saying. No, that's definitely going to be 0, 1, and 4. But my question was, what am I going to put as the label in that y column? X of t, right? We want to know when that position is the biggest and when that position is the smallest. So that's what we're plugging those t values in. Really, we only had two choices, x or v. it wouldn't make sense to plug into v anyway because you know that t equals 1 is going to give you 0. Like we're looking to find something else, something that we don't already know. Okay, so let's see, what do we get? When we plug 0 into x of t, we get, yep, negative ln 5. When we plug 1 into that, what do we get? 3, ln 3. 1 minus 2 plus 5. 6 minus 2. I get 4, don't I? Yeah. Negative ln 4. And when I plug 4 into it, I get... Cool. Perfect. All righty. Starting with, let's think in terms of absolute value here for a second. Which of those three things, ln 4, ln 5, ln 13, is the biggest? ln 13. ln's an increasing function, so the bigger the x value you put it in. But they've got negatives in front of it, so that means that negative ln 13 is the smallest, right? So yeah. So it is furthest to the left. Yep. Left. What it says, when is the particle at t equals 4? Always watch to make sure what the problem's asking, right? If you say the answer is negative ln 13, you're wrong because it says when is the particle. And then to the right, what's the largest value there? Negative ln 4. And that happens at t equals 1. Kind of like the example I was talking about yesterday, one of those answers probably could have been solved by making the sign chart, but the other one couldn't have been. And I think the answer that we could have said was, it was furthest to the right at t equals 1, because if we look at our sign chart for v of t, we have a critical value at 1, we have hard stops at 0 and 4. Our derivative always has a negative component to it because of the minus out front. And 2t minus 2 is negative before it hits 1 and positive after. Agreed? So the orange negative just comes from the fact that there's a negative coefficient there. It's negative this fraction. And the blue represent. So our function is increasing and then decreasing, and that's all it's doing. So that's why we are the furthest to the right at t equals 1. Make sense? That's extra, right? I mean, it's just pointing out that not every single problem in the world says you have to do it this way. But since we asked for both left and right, doing the table makes the most sense. Of course, that comes from the fact that these are overall positive and overall negative. Okay. What is the maximum speed of the particle? Speed's a tricky one. This is the one when I say like almost every problem has a something that we've done in the just function world. Speed's a little bit different because what is speed? Absolute value of velocity. So we don't really do that too much in the function world, like just, the non-particle motion problems. So this one's a little bit different, but the key is we want to think about velocity. We're going to look at velocity, but when we make our table, instead of having velocity in the y column, we'll put absolute value of v of t, okay? No, this question can kind of go both ways. If I say minimum speed, if this thing ever hits 0, that's your answer. You know what I mean? That's kind of an oddball thing to this question. If it's always...
At this time, all students...
No, keys down here. If your particle only travels in one direction or the other, the minimum speed will be a value. But anyway, my question, I didn't want to add any of that nonsense into this question. I just said, what's the maximum speed? So if I want the maximum speed, I need to find the critical values of what function? Careful. But answer my question. You're right, but I need to find the critical values of what function? X double prime of t, right? I've got to find the critical values of the velocity. Because the velocity can only hit a minimum or maximum, a relative min or maximum, at a critical value. I want to know when that velocity hits a critical value. So I think you can get away. I mean, there's nothing wrong with it. I think we just need to say that v prime of t equals 0. I don't think there's anything about this problem that's requiring us to identify that v prime of t is acceleration. That being said, if you're in autopilot and you just want to say a of t equals v prime of t, nobody's taking points off. You know what I mean? But that's what we need. We need the critical values of velocity because we want to figure out when that velocity or the absolute value of it is at a maximum. Okay, so we have a little bit of a derivative defined. What do we need to use? Quotient rule, we know that one. So v prime of t is going to be something over the quantity t squared minus 2t plus 5 squared, which if you didn't realize it was always going to be positive before, now it definitely needs to be positive because it's a thing being squared. And I probably didn't give enough room for my numerator. The bigger my screen is, the better my lines look somehow. But let's see what we get. All right. So it looks like we have derivative of the first. We probably need a negative out front if we want to get a right answer. 2 times the quadratic, t squared minus 2t plus 5, minus, because it's quotient rule, 2t minus 2 times 2t minus 2, right? Yeah, because the derivative, they're both, in both cases, to get that 2t minus 2, we had to take the derivative of the denominator. All righty. So we have some fun in front of us. We have a big negative. That would be the answer if that's all we needed to find. It looks like we have 2t squared minus 4t plus 10. Yell at any point if you disagree. Minus the quantity, 4t squared minus 4 is minus 8t plus 4. Cool. All over, blah, blah, blah. T squared minus 2t plus 5, but squared. Boom. Okay, which is negative and has a 2 minus 4, so a negative 2t squared. If I have to factor this, I'm going to distribute my negative in. Negative 4 plus 8 gives positive 4. Positive 10 minus 4 gives 6 of a positive variety. Agreed? Correct. Cool. Over the denominator. T squared plus, and by plus I mean minus. Whole thing, but squared. Cool. All right. So factoring. Let's pull out a negative 2 from the quadratic. Put our negative out in front. And we end up with t squared minus 2t plus 3. Minus 3. Because I'm factoring out a negative 2, correct? Yep. All over this guy. T squared plus minus 2t plus 5. I really want that 2t to be positive for some reason. Boom. In a world of making things slightly better, a negative fraction times pure multiplication at the top, a negative 2, those two things turn into positives. So cancel those out. And finally, we end up with something that we can factor to get our critical values over something that we do not need to factor. T minus 3 plus 1. What did I forget? Yep. Good stuff. Boom. A chain of a million things being equal on an APFRQ. You drop a 2 or something that really doesn't matter for our answer, loses points. So just be aware of what you're doing. It's easy to make those mistakes. So what are my possibilities? 3 and negative 1. But only one of those is really a possibility. It would just be 3, right? Because the function says t equals 3, t equals negative 1. If I graphed it, those would be possibilities, but I have that original domain restriction. So I do not need to consider t equals negative 1. All right, so I will make my table. In my left-hand column, I have t. This time I have 0, 3, and 4. And what do I have in my y column? Yeah, absolute value of v of t. Yep. All righty. So we're going back to v of t. So we've got to plug 0 into both. That's easy. I get -2 over 5. I think the other ones won't be that easy. And by -2 over 5, since, yep, regular. Not -2, but regular 2 over 5. Definitely the better way to say it than +2. I mean, with 3, looks like 6 minus 2 in the numerator. Make this, oops, sorry, make this a little bit bigger here. So 4. What's that? Denominator, 9 minus 6 plus 5. 3, 8. Yeah, okay. Which is 1/2 last time I checked it. Hey, these are things we can do in our head. And then 4, that's going to give us 8 minus 2, which is 6 in our numerator. 16 minus 8 plus 5. Okay. That's going to be 8 plus 5, 13. Yeah. All right. So when is it traveling the fastest? What's the biggest fraction there? 1/2, yeah. Definitely 1/2. Yep. Yeah. 2 is less than half of 5. 6 is less than half of 13. Yep. And it says, again, what is it, the maximum speed? The maximum speed? Boom. So, yeah. Hey, we know a lot of calculus, don't we? Some of us. We do. We just need practice. That's all we need. You know what? I was kind of sloppy on my other ones. I said it's good form to just always do it, and I should have, yeah, I kind of left that go up at the top, but yeah. Do you have to do it? No, you have to answer the question. If you always write both, as long as you have both, then you've never not answered their question. Giving them the extra piece of information is never going to lose you points if it's correct. All right, questions on that? I think the 2 questions in the practice kind of, you should be able to mirror them from what was kind of written here. So we'll go from there. All right, we will put a stop to that and we will start